Hello, kids of the 8th grade. Today, I will teach you about sequences. First off, what is a sequence? Well, a sequence is a particular order in which related events, movements, or things follow each other. An infinite ordered series of numerical quantities. So, there are two types of sequences. There's an arithmetic sequence and a geometric sequence. An arithmetic sequence is a sequence where there's a common difference, which involves addition and subtraction. Except you don't really subtract, you more of add negatives, but it works the same as subtracting. There are two types of formula that go with each type of sequence. There's the explicit formula, and there's the recursive formula. The explicit formula is the formula of just an equals a1 plus d times n minus 1. The a is just to show that it's an arithmetic sequence. The n is supposed to represent the nth term, which is like any term, or whatever term you're trying to find. The 1 is supposed to represent that the a1 is
not only a steak sauce,
but the first term in the sequence. Then d is supposed to represent the common difference. And then the n minus 1, the thing is with sequences, the first term is just the first term. It's not like 0, but it's just 1. When it's term 2, you would replace the n with 2. 2 minus 1 is 1. And you can see an example here. 2 times 2 is 4, right? So you have 2 times 2 equals 4. 4 plus 2 equals 6. And that's when you wonder, maybe that's why we subtract by 1, because we start on term 1. This isn't just 0, but this is term 1. This would be considered 1 with like the common difference, but this is just term 2. So that's why we subtract by 1, since everything's off by 1. So yes, with this example, 2, 4, 6, 8, 10, we want to find the 6th term, since we only have 5 terms. So we would replace the n with 6, replace the d with 2. So we have 6 minus 1 is 5. 5 times 2 is 10. 10 plus 2 equals 12. 2, 4, 6, 8, 10, 12. Makes sense, right? Now, onto the recursive formula. The recursive formula is used to find a term using the previous term. So you have an equals a n minus 1 plus d. There's a difference. Instead of the n minus 1 being after being multiplied to the d, the common difference, it's the term. So it's the previous. So say you're trying to find the 6th term, right? a6 equals a6 minus 1. That's the previous term, because since 6 minus 1 is 5, the 5th term is 10. So this would be 10. You add 2, since that's the common difference, and you get 12. Just like what we got with this formula. Yes. And that's what we got with the arithmetic sequence. Now on to the geometric sequence. For our geometric sequence is a sequence where there's a common ratio, which is involving multiplication and division, but you're not really dividing. You're just more of multiplying fractions, which is the same as dividing by a whole number. So we have the same two formulas, the explicit and recursive, but since we have a geometric sequence, it's not the arithmetic, so it's going to be different. So the explicit formula is gn equals g1 times r to the n minus 1 power. G just representing that it's a geometric. Everything else is the same except r, it's different. Instead of d, we have r, because that's common ratio. And then we have to the power, since we're just multiplying and multiplying and multiplying. So say you have something like, you have a sequence like 2, 4, 8, 16, 32. You would implement into this. G1 is 2, so we would put 2. We need to find the sixth term. So 2 times 2 to the 6 minus 1 power. 6 minus 1 is 5. 2 to the 5th power is 32. 32 times 2 equals 64. Check the math yourself. It's right. It's right. I'm telling you. Then we have the recursive formula, which I said before, used to find a term using the previous term. We have gn minus 1 times r, so the only difference is it's times r. So substitute all that in. G6 minus 1, that's 32. 32 times 2 is 64. Basically, this is just the same as this, but you had to know the previous term. That's all we have for the geometric sequence. Now, on to a topic of how sequences are related to functions. How they are related to functions is that a sequence is just points of a pattern, and the function that's made for it is just the average that is in between the points of the terms. And when you make the formulas into functions, you get a linear function with an arithmetic sequence and an exponential function with the geometric. You have f of n equals mx plus b. How you would change this formula to a function is do distributive property and then combine like terms, and then when you have dn, n would be x, your x axes, and then d would be your slope, and then whatever you got from the a plus d to the negative 1 power, that would be your y-intercept. And for the geometric, you would just separate the two, so you would have r to the n power times r to the negative 1 power with the g1 times all that. So combine like terms, and then the r is your m, your r is like the x is your m, is slope, and then the n is your x. That's superscript, whatever. N is your x, and the r, the common ratio, is your slope, and g1 times r to the negative 1 power is your y-intercept, as we can see, b. Now, we have a few questions for you to solve. We have this pattern, negative 13 to negative 7.5 to negative 3 to 1.5 to 5. What is the pattern for the sequence? Is it geometric or arithmetic? What are the formulas? As in, what's the explicit and recursive formula for it? Then you use that formula to find the 193rd term. Then, with that, can you make the function for it? That's for our question number 1. Then we have question number 2. 1,000 to 400 to 160 to 64 to 25.6 and to on and on and on. What is the pattern for the sequence? Is it geometric or arithmetic? What are the explicit and recursive formulas? And with those formulas, what is the 1923rd term? And most calculators will round the answer to 0. That's just a little hint and a limit. So you have to figure this out on your own, because a calculator would just round it to 0 for you. And then you also have to find the function. Make the function, which is like either you do distributive property and you combine like terms, or you separate the power, so you have r to the nth power and r to the negative 1 power, and then you combine like terms from there. And you change gn to f of n and an to f of n to show that it's the function of that term. So yes, those are the questions you just need to solve for these two sequences, and yes, thank you for watching.